Welcome. Today we are talking about important inventions. Justus von Liebig is the father of the mineral fertilizer, and the mineral fertilizer solved the tremendous problem of poverty and starving in the middle of the 19th century. Justus von Liebig is very important because he identified the various components necessary for growing plants, and he also distinguished between essential ingredients which should be present in the soil because the plants get them from the soil, and other ingredients which Liebig postulated can be taken from the air. And one of his premise was that nitrogen is never a problem for a fertilizer because the plants get enough nitrogen from the air because the air is 80% nitrogen. But so ingenious Liebig was in the very beginning of his mineral fertilizer. He had big problems in producing a working fertilizer helping the farmers and the food production. The first reason was that he assumed that the minerals in the fertilizer should be poorly soluble, otherwise they get washed out and cannot be introduced into the plants. While there was some merit in this idea, in practice it turned out that the mineral fertilizers developed by Liebig were almost useless because the minerals were so poorly soluble. Only once English colleagues realized that the soil as such can absorb minerals and act as kind of a sponge for the plants, which can then take the better soluble minerals from the soil, the Liebig fertilizer was more successful. And it was certainly very important that Liebig acknowledged that finding by colleagues and competitor scientists. The second hypothesis was that nitrogen is available from the air in excess. This was key to the original scientific explanation Liebig had for many of his theories, and it was merely a basis for his work in the beginning. But at the end it turned out that the plants are not able, most of them are not able to get the nitrogen out of the air and into the proteins and the molecules important for the plant growth. So Liebig needed about 10 years to realize that nitrogen from the air was not useful, and the remainder of nitrogen present, for example, in humus and rain was way too low. So once he admitted his error, the breakthrough for mineral fertilizers came. And if this finding wasn't there, we certainly would be still in an agricultural society and would have basic problems in providing enough food for the people getting the people healthy, avoiding starving and serious health issues. So Justus von Liebig's contribution is enormous for our modern society. And nitrogen, phosphorus and other minerals are essentials for our food and farming, and we can hardly imagine the severe problems of the 19th century where all these elements were absent from soil and therewith from the plants. So today we have more the wealthy problem that we should avoid getting too much of fertilizer on the soil, but we certainly should never forget that fertilizer, be it natural or chemical, is essential to our food production and to our public health. And still today we need to add nitrogen to the grounds. Germany was in the 19th century making much progress in classical chemistry. So it is no wonder that the first patent filed in Germany was in the field of chemistry. Liebig filed a patent in England. The English society was then the leading society in the field of fertilizers. And the patent system in Germany was not developed in that time. So it took 30 years more for Johann Zeltner from Nuremberg to file the first patent in Germany. It was directed to a dye molecule, a violet derivative of the blue ultramarine dye. Ultramarine is a natural mineral, kind of a silicon composition, which is on many famous pictures from the Renaissance, so from the 15th and 16th century. Very intensive color and very persistent as well. But Zeltner found out that a modification of the molecule can produce a very useful violet color. Getting back to the concept of what they called bread from the air. So Liebig started with introducing nitrogen from the air into the plants to get a promising plant growth and to overcome the severe starving problems of the 19th century. There were many follow-up problems, and one of these problems was that in order to produce enough fertilizers, the molecule ammonia needed to be synthesized from the elements, so from nitrogen from the air and from the H2 molecule, which is of course a synthetic molecule, but synthesizing this molecule was not a problem at that time. The truth is, of course, there were other goals for producing ammonia. For example, the critical situation before and during World War I required that the German emperor had enough material for the industry, including for weapons, and for many of industrial products, ammonia then and today is a basic product. So many of the nitrogen-containing chemicals require ammonia as an adduct. And the synthesis of ammonia is fascinating because there were so many scientists trying to do the synthesis, and there was already, I guess, a method available which used anorganic chemistry, but it was not possible to produce large amounts from just the two elements H and N. And the very famous German chemist Ostwald had failed to provide a successful ammonia synthesis, although he was of the opinion that he had already invented the synthesis. When other colleagues tried to rework his invention, they found out that the nitrogen was not from the air but from impurities in the catalyst Ostwald has employed, and as a reaction Ostwald withdrew his patent. The Haber-Bosch solution to the problem relied upon high pressure, high temperature and a specific catalyst, and it was never thought before that under such harsh conditions catalytic synthesis would work. And it worked in such an extent that the world production of ammonia could rely upon this synthesis. Of course, there are many follow-up inventions to improve the synthesis now, but what you see here is the German patent from 1911, granted from 1911, and the only claim of that patent is on the left on this slide. So it was not only about anorganic chemistry, but also organic chemistry was very far developed in Germany. So at the beginning of the 20th century, Adolf Butenandt identified at least 3 of the most important sex hormones, so female and male sex hormones, and he even got a Nobel Prize for the identification of these sex hormones. And the patent I found from that time was a synthesis of estrone, the molecule on the right top of the slide, which is correctly depicted on page 1 of this original patent here on the slide in the middle. So it's the molecule on the bottom, and the molecule on the bottom is synthesized from estradiol, the molecule on top, which had apparently been published by one of Butenandt's colleagues. So Butenandt identified the estrone molecule and provided even a chemical synthesis of the molecule at that time. And that was a time where there was no opportunity to identify this very complex organic molecule, the structural formula of this molecule, by way of spectroscopy like NMR, as we would do today. So fascinating, pioneering work by Butenandt.